Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments. Tonight, we're going to take a look at some spooky stories that stimulate student thinking. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI Technology to make those tough to teach, tough to learn concepts accessible to all my students. I'm super excited to be joined tonight by Cassie Whitecotton and Jeff Lukens. Mrs. Whitecotton earned both her degrees, a bachelor's in physics and a master's in STEM education from the University of Texas at Arlington. She currently has 8 years of teaching experience at the high school level in the math and physics classrooms, 3 of those being in engineering education. Continuing her path in education technology in 2010, she became a science advocate for Texas Instruments, using the TI-Nspire CX handheld with the TI-Nspire Navigator system in her classroom with her students. She began delivering professional development to other science teachers at well-known conferences such as Conference for Advancement of Science Teaching and T-Cubed Teachers Teaching with Technology International Conferences. In the spring of 2014, she became a T-Cube regional instructor for science and STEM education with Texas Instruments. Cassie, thanks so much for being with us tonight.
Thank you for having me.
And when he retired from teaching in 2014, Jeff had taught high school science for 34 years. He now delivers professional development across North America for the Teachers Teaching with Technology organization as a full-time science instructor. He continues to author activities for all levels of science teachers and learners. Jeff, thanks for being with us.
Thank you, Mike. Good to be here with everybody.
We're expecting a large crowd tonight, so your audio is automatically muted. You can send any questions during the webinar to Cassie or Jeff. As a reminder, we'll provide a link to the event certificate of attendance at the conclusion of the webinar. We hope you don't have any audio issues tonight, but in the event that you do, try selecting Communicate from the WebEx menu, choose Audio Broadcast, and then click Join. At this point, Jeff is going to discuss our agenda.
Okay, Mike, and once again, welcome everybody. It's good to have you all here for what we think is going to be kind of a fun hour together with our spooky stories that we're going to be sharing with you, which is appropriate since, a little less than 2 weeks. We got Halloween coming up. As Mike did all the welcome and introductions, that's item number 1 off the agenda. It's going to be kind of fun. You guys are the first ones who are going to see this brand new activity that just got posted on TI's website called Haunted or Hoax, and Cassie's going to take us through that one here in just a little bit, and I don't want to spoil that for anybody, so just be ready for that, and if you're a ghost kind of person, I think you're going to dig that. And then I'll take you through parts, anyway, of our very popular STEM Behind Hollywood activity called Zombie Apocalypse. So we'll do that when Cassie has had a chance to share the new activity with you. At the end of our webinar tonight, Mike will talk about some online resources that are available. And in fact, Cassie's actually going to start us out by looking at some of the online resources. And then I'm sure Mike will follow that up at the end of our time together with some things that are available to you free and online. And then one thing that if you're a regular webinar, Tuesday webinar junkie with TI, this is a big deal. There's a giveaway at the end of tonight for registration, complimentary registration for the T-Cubed International Conference, which is in Chicago this year. So we're hoping that we have a lot of you who come on to these webinars and eventually will get one of those complimentary registrations. So there you go.
Jeff, thanks so much. Cassie, it's all yours.
All right, guys. Good evening, everybody. So first I wanted to show you where you can find our new activity. So if you go to education.ti.com, you will get the brand new flyer that comes up, and you'll see the new STEM Behind Hollywood activity. So if you click on that, it will automatically pull it up. And so our new activity, of course, is Halloween themed, and it's haunted or a hoax. And so if you think back a few years ago, and even still now, there's lots of TV shows out there about ghost hunting and witch hunting and all this stuff. So we felt it necessary to bring some science into the ghostly world and how we can use technology and science to discover whether it's haunted or hoax. And so this activity is written around a show called The Ghost Nabbers and Biker Bob. And in the activity, students are introduced to the concept of electromagnetism, and they're going to look at the relationship of wavelength and frequency, and some practical applications of electromagnetic principles that are used in everyday life today. Here on the page, you can download the files, the TI-Nspire file that goes with the software, your student worksheet, the teacher notes, or you can download the whole zip file. And so on this activity, much behind of our STEM, behind Hollywood activities, we consult a professional or somebody that has spent years, doing research to help us write these activities. And Adam Weiner from the National Academy of Sciences consulted on this one. And he is a teacher, a science teacher, and he gave us some great insight on how to use the activity and the principles that the kids are going to dive into. And there's also a free version of the teacher software on the link. So let's get into the activity. So when you download the activity, this is what you get. Is it haunted or a hoax? So the scenario is based around Morgan, a photojournalist, that is called in to analyze the TV show Ghost Nabbers because they're having really good ratings and they're very popular, but they have yet to find any ghosts. And it goes into some background information about the E&M spectrum for students and kind of what the E&M spectrum is. Talks about gamma rays, X-rays, ultraviolet light, visible light, infrared, microwave, and radio waves. And it talks about the different colors of visible light and what those wavelengths are. So students are exposed to units such as nanometers. And there is a great graphic here. So with a slider that starts at 300 nanometers, and as they move the slider, the wavelengths appear, and up here, it will display the current wavelength in the top right corner. And so they can slide this, and they see that as they increase their wavelength, the wave gets bigger. And it also goes through the colors. And then it becomes invisible. So as students can move the slider back and forth, they can be making observations at what happens when they're looking at the crest of the wave, the trough of the wave, or from crest to crest. What happens to that physical distance? And they can also document at what colors the wavelengths appear. So green, yellow is around 475. Orange is around 526. And so they can be recording their observations on their student handout at what colors appear at what wavelength. And then if they reset, So then there are some student questions about why you can't see past the red end, and hopefully they would answer that they get outside the visible light range, and what range that would be. And then it goes into, like I said, crest and the trough. parts of the wave. And then here, there's an electromagnetic spectrum diagram. So if they're outside the red, they're getting into wavelengths of the microwave. If they're outside purple, they're getting into X-rays. Again, there's another question. And so which of the following are useful tools that are based on the E&M spectrum? So again, it has some practical uses. And so it is a square box, so there's more than one correct answer. And so almost all of these are E&M spectrum waves. And so then it goes back into the story of Morgan, and they talk about photography and what the aperture is, and the opening of the lens that allows light through the camera so that the picture can be taken. And here, if this is the lens of the camera, then they can open the aperture, and what they see varies quite differently as they open that aperture, and they vary the amount of light that comes in. And they can see that the area is varied. So here, what I like about this is that, oh, you have a nice, pretty picture, and as I let more light in, it looks like I have a ghost. And so then there's some questions about photography and what skills. So there's lots of students out there that like to take pictures and are involved in photography. And then here there's more background on the speed of light, so that we know C is known as the speed of light at 3.0 times 10 to the 8th meters per second. And frequency is in hertz. And then wavelength lambda is measured in nanometers. So this is probably new for students if they haven't seen this before, what the symbol is. Teaching physics, it's always very common that students forget the symbol being wavelength. And again, it talks about how gamma rays are dangerous because they're small enough to have enough energy to cause damage to your DNA in your body, where X-rays are slightly lower, so that's why we use them to take pictures of our bones, because our bones are highly dense. And then UV light is also damaging, which is why sunscreen is useful. And so here, there's a question about how a longer wavelength means a lower frequency. Yes, no. And again, they have to rearrange the equation for how to calculate frequency. So algebra skills are vital here. And so then it goes on for Morgan and the hunt. And so the hunt begins at Dead Man's Curve, where several accidents have occurred. And they're going to use a piece of equipment called the specter spotter. And the specter spotter looks like this. And so it can detect wavelengths in the infrared and ultraviolet. And the software, the spotter converts these signals which can't be seen with your eyes into images. So it creates it on your screen. So Morgan meets them at the location of Dead Man's Curve, and she starts to begin asking questions for our article, and she gets pretty snippy, in my opinion. So she knows her science, it seems. How can ghosts reflect light if they have no mass? And Nabber from the TV show changes the subject. And is it possible the accidents were caused by the poor design of the road and not by her boss? And then the guy from the Nabber from the show runs off. And it talks about infrared. It has a longer wavelength, so the kids can refer back to the ultraviolet and electromagnetic spectrum to see where it lies. And so here it talks about sightings where Nabber puts on the spotter and begins to walk around and in the safety area because they've got it closed off. And the Nabber all of a sudden gets really excited. And so we're about to see what he's so excited about. So here, this is our standard visible light view. And there's a slider down here. So if I go to lower wavelength, I see it light. If I come back to visible light, oh, there's Bob. So if I go to my UV settings, then all of a sudden I get a ghost. And there's ultraviolet and infrared. So the kids can play around with that. And you see biker Bob in the ultraviolet. So she starts looking for an explanation, and the nabbers are excited because they found evidence of biker Bob. But she starts to answer some questions, why there was a dark shadow at the IR setting. So if they look, the shadow is really dark compared to the rest of the setting. And their explanation was that they're colder, ghosts are colder than air, and the spotter creates an image that shows hotter objects as white and colder objects as black. And the darker shadow must be a ghost. Well, she keeps questioning, and so this is her question, why does biker Bob disappear once he was detected? And they say that they believe ghosts can materialize at will. Once biker Bob realized we could see him, he disappeared. But she argues, well, if they have no mass, how can they materialize? Asking if they can explain. And the nabber says, oh my gosh, look at the time, we have to leave. And so she starts digging a little further. The nabbers leave the area to celebrate that they had caught biker Bob on camera. But she starts taking some pictures, and she notices that the guardrail around the curve, there's a small device attached to the well. And it's one just like it attached to the tree, where both places were biker Bob spotted. So she takes pictures of the devices, and they are known, what they call it, AVI or RFID. So an AVI is an automated vehicle identification, radio frequency ID. So this is similar to toll tags. If you have a toll tag in your car, it sets off automatic toll. It sends out a radio wave. And yeah, it gives them some background on what the radio waves are and how it works. And so it does happen at the speed of light, so you don't have to slow down. So she finds these two tags and realizes that they're sending a signal to the specter. And so here then the students have to do a calculation with the known frequency. So at 928 megahertz is the frequency. So they would have to be given or know the times 10 for the mega. And then they can calculate the wavelength in nanometers. So they would have to make that conversion just to hertz. So the spotter of a radio, and when the RFID tags activate the software, then it automatically pops up with an image of biker Bob. And so Morgan is really excited because she has broken the case of the ghost nabbers and taken, in fact, that she can use her science, the E&M spectrum, UV, radiation, and visible light all into account, and that they use those concepts in order to try to fool their fans for TV purposes. And then it says here, light can only reflect off of matter. And then astronomers use radio telescopes to detect objects in space. What do you think the term radio refers to? So we would hope that they would get the idea that radio is a radio wave, much like the radios in their car. That's what it's receiving. Here, the telescopes are receiving radio waves and doing analysis on them. And then Morgan had just used her skills to reveal a conspiracy for the TV show, and her knowledge of the E&M spectrum and application helped uncover that. So that is our brand new showcase of Haunted or Hope. And this does, give kids a practical application for E&M in a fun way in which they don't usually think about. So especially in photography, the amount of light you let in adjusts the amount of pictures and the exposure. And then also the use of the electromagnetic spectrum for RFID technology, and that it can be used in practical ways. And so, happy Halloween, everybody. Any questions?
All right. Cassie, why don't you just throw that control up there to me, and I'll show my desktop so I can start showing you guys the next activity. Thanks, Cassie, for doing that. That's exciting when new activities like that come out. It's really cool because, well, for one thing, you guys are the first ones to see that, literally the first ones to see it. I think it went up live on the web either yesterday or maybe on Friday. But when stuff like that comes out, I always get excited because I want to go in and see what kind of cool stuff that the Inspire can be made to do, and that's a really neat thing. I saw some of the comments, Cassie, as you were doing that, about how the coolness of when you change the wavelength on that spectrum and the colors change. That's really one of the most important things about TI-Nspire is not only the dynamic of being able to change things immediately on the screen, but also to colorize stuff and to have things change color and so on. And we think that's a really powerful learning tool as well. Okay, we're kind of doing the bookends of the STEM Behind Hollywood thing tonight. The most recent and newest activity is the Ghost Stories one that Cassie just did, and the very first STEM Behind Hollywood activity that we did was this one, and this is called Zombie Apocalypse. And there actually were 2 zombie apocalypse activities made, and this one, Zombie Apocalypse, and then we get really creative with our naming process, and we just called it Zombie Apocalypse Part 2. So we kind of took a page out of the Rocky Balboa series, Rocky 1, Rocky 2, and so on. So I do want to do a little shout out as Cassie was presenting that activity. I saw in the chat window, this is for some of you, your very first webinar. So welcome to those of you who this is your first webinar, and welcome to those of you, and you know who you are, that this is like your 100th webinar, because some of you never miss on Tuesdays. And we're really hopeful that those of you who are newbies to our webinar series will find it helpful enough to come back again next week and continue to join us. This activity, I'm not going to go through all the stuff that Cassie did on the website, but just to let you know, all of these STEM Behind Hollywood activities were developed with the help of an expert in the field in which we generated the activity. So as Stacy showed you, Adam Weiner was the one who helped us with the ghost story activity. With this one, there actually, yes indeed, is a zombie expert that organization called the Science and Entertainment Exchange provided for us, and he's actually a professor at the Harvard Medical School and a really cool guy. His name is Dr. Steven Schlossman. And our cover page here in the Zombie Apocalypse is actually a picture from a novel he wrote called The Zombie Autopsies. So if you have an opportunity, check it out. It's a quick read, really cool. And if you're into zombies, might be kind of a fun thing for you to take a look at. Okay, so let's zip through this one and look at some of the cool things that are learning moments for your students, and also maybe kind of the hook that you can get in these kids to. What I always found was if you can get a hook in them, you can pretty much take them anywhere and teach them anything. And so if it takes zombies to do that, then I'm all for it. So here's our scenario. We have zombieism, which is a contagious disease. And this is a virus that is airborne, so that's realistic. There are lots of airborne viruses. Usually they kind of hang around in like little droplets of water when you sneeze them out or something like that. We always include a little bit of reading in these activities, and when we do, we can include big words like that. This one right here that I just highlighted, which is pronounced epidemiologist. And it's amazing when kids get these activities in front of them on their calculator or on their iPads or on their computers, they actually read this stuff because they've already taken the bait. When on that first page, when they saw the guy turning into a zombie, they're already interested. So many, many times kids will ask you, what's an epidemiologist? And essentially an epidemiologist is a disease studier. So like the Centers for Disease Control in Atlanta are just crawling with epidemiologists because that's what they do. They study diseases and how they're spread and how to prevent them from spreading even further and so on. So we get this scenario set up. And then we talk about how this virus or this particular, in this case we're going to call it a virus, affects the brain in a way that people will become zombie-ish. And another really, you kind of take it for granted, but some really cool things that you can do here with Nspire and also with the 84 CE is you can colorize stuff. And so here are the different parts of the brain that Dr. Schlossman, who is, our expert on this, said would be impacted if somebody started showing the characteristics of a zombie. And I do want to make mention of something. Even though the zombie thing is not real, I hate to burst the bubble of any of you who think it is, but Dr. Schlossman says even though full-blown zombieism is not real, they do exhibit characteristics that are similar to other diseases that humans get or that other animals get. For example, most people are familiar with the moniker mad cow disease. That is actually something that is very similar to this zombie virus, this made-up zombie virus. But here are the parts of the brain that Dr. Schlossman said would be affected by this virus because of the characteristics that somebody has once they start turning into a zombie. And so if you look at the colors here, the cerebellum, which is in blue, we colorized it the same on the brain diagram. Here it is. Here's the frontal lobe, which is another, it's a piece of what's called the cerebrum. And then in the middle of the brain, we have these two kind of obscure little hunks of brain tissue called the hypothalamus and the amygdala, which will come into play here again in just a minute. We like to make sure that things are readable to kids. Not only are they engaging, like here we got the zombie thing going and the kids are really excited about it, but we also like to make it not so miserably difficult to read it. So we put things in pretty simple terms. Zombies clumsily shuffle around because the cerebellum controls muscle coordination and so on. This is my favorite. Zombies aren't nice. They are full of rage. And that's the part of the brain called the amygdala, which kind of has the nickname the crocodile brain, because this is the part of a brain of a reptile that's actually pretty big, whereas the thinking part of their brain is not very big. And by the way, this was, everything was A-okay until World War Z came out, that movie where the zombies all of a sudden are not clumsily shuffling forward. They are actually sprinters who can run things down, which completely threw a wrench into this, the zombie genre type of thing. But nevertheless, most zombies are portrayed as sort of not having a whole lot of common sense or muscle coordination or whatever. This is a gentleman who volunteered to turn himself into a zombie. This guy's name is Ryan, and he is a graphic designer with TI. Don't tell your kids that. Tell them he's like a normal, regular old person who gets infected with the zombie virus, because when we click on play, we can see that this poor guy is going through these stages, and this is in a loop, and it'll keep going and going and going until we decide to stop it. But you can see that Ryan is morphing from this pretty kind, gentle guy with, yes, he does have a mohawk, into somebody who's got all these kind of nasty looking things all over his face, and he looks pretty ticked off at the end of this thing. So as you kind of watch this, the kids, when they first watch it, are watching Ryan. I think human nature is to focus on someone's face, but then they start to look over here and they can see the cerebellum and the cerebrum starting to get shrunk up. by the activity of this virus. The fancy name for that is atrophy. And these start to get red, the amygdala and the hypothalamus, which means they're infected, and it takes us through the stages here. And you can actually pause these in different stages to watch what happens step by step and so on. So again, if the hook hasn't been embedded yet by page 1.5, by now the kid he has swallowed the bait. He or she has swallowed the bait, and they are ready for pretty much anything. Keep in mind that these activities are called STEM behind Hollywood, S-T-E-M, and that's in most places around the country. And I know we have some worldwide people joining us tonight, and I'm not sure, I can't speak to the prevalence of STEM in other parts of the world, but I would anticipate that even if the acronym is not used, the idea certainly is a good one, and it is used in various parts of the world. And that is, when you talk about STEM, it's important to make sure we include a discussion of the science, which we are in the process of, and also the mathematics. So when you take a look at this page, this is going to lead us, it's kind of a spoiler alert. This statement down here is like, when you turn the page, is like the biggest letdown ever, or seemingly the biggest letdown ever, because we have a graph that's going to show up. So the kid gets to the point here, and they're looking at the bottom of the page, and they're like, I can't wait to go look at this scary, and then they get this, oh man, that's not scary at all. Well, this is a great teaching opportunity, because if you know anything about the spread of a disease, or you know anything about population growth and how we graph that and put data to it, this is indeed really scary. I'll give you a couple examples, and then we'll move on to some more of the mathematics. In Dallas, Texas, the very home of Texas Instruments, about 1.5 or 2 years ago, and if we had some feedback, I could ask you a big event that happened in Dallas, Texas, with a nurse who got infected with something. And I would bet, I can't see the chat window, but I would bet you that there's a bunch of you who know what I'm talking about. And let's see. Oh, annotate, I don't want to annotate. There's a young nurse got infected with Ebola. And when I say a young nurse, that's singular. One young nurse got infected with Ebola. And the entire metroplex of Dallas, my friends who live there, I don't live in Dallas, my friends who live there say, yeah, everybody was in a panic. And that's because one person had this. And Dallas is a metroplex of several million people, and there was panic because they wanted to make sure this did not happen. And if you hover over these dots, at week 1, we had 3 zombies. At week 2, we had 9. It doesn't look like anything's happening here, but as a science or math teacher, you know something's got to be happening, because this thing takes off at about week 7. Another example of this is the spread of the influenza in the wintertime. I happen to live in South Dakota, and we have a lot of small schools in South Dakota. And let's say on Tuesday, some kid is absent from school because they have the flu, and on Wednesday, 3 kids are absent, and Thursday, 5 kids are absent. Next Monday, they probably are going to close the school because they're trying to prevent something like this from happening. So this actually is a very scary graph if you're talking about the spread of a disease. If you're talking about it just as a graph with no labels on the axes or whatever, maybe it's not that scary, just looks like an exponential growth model. But if you apply a real life scenario to it, or even if it's zombies, not so much real life, but a real spread of a disease thing to it, then it does indeed become quite scary. We're going to take a look at another series of graphs here and talk about the mathematics and the analysis of them. We're going to look at a word, big fancy word called virulence, which is basically just says how bad is this thing? How easy is it to get it from some other person? Common example would be like chickenpox. The chickenpox virus, when I was a kid or when my own children were young, was pretty prevalent. Everybody pretty much got the chickenpox. Chickenpox is incredibly virulent. I mean, it's very, very easy to get from somebody. It's usually not fatal. It usually doesn't cause severe symptoms, but it certainly does cause some symptoms, and it is very easy to get. So that does have a fairly high virulence. Okay, let's check out this graph. We actually have two graphs here on a split screen. Another beautiful thing we can do with Nspire, split a screen, show two completely different representations on the same screen. Tucked down here in the lower left-hand corner, we have this little toggle where we can actually change the virulence. And I believe the lowest virulence is 1, and the highest virulence is 10, I believe, yeah. And so let's just kind of do the 3 of these. We'll do a virulence of 1. So this just means that it's really not that contagious. So be thinking now about what you think you're going to see over here. We have a time. It doesn't say days, weeks, or years, or whatever. Just some relative amount of time from 0 to 36-ish. And then we have the number of zombies. So if this thing is not very contagious, then think about how that graph over on the right is going to look. And I'm going to go ahead and start this in the interest of time and just let this thing run. And with a virulence of 1, you can see on the left side, the box graph, that the red squares, which represent zombies, are filling in. They're just filling in fairly slowly, and you can see a pretty gradual change or pretty gradual increase of the number of zombies over on the right side. And this takes several seconds to run, and you can see the scoreboard. Here's humans, here's zombies. You can see a visual, and you can actually see a graph being generated. So once we reach the end of that, the plot of 36 whatever units, let's say that's weeks, we're still running it over here, but this hasn't even maxed out yet. So let's go ahead and reset that, and that was a 1. Let me go to 5, and we'll see how this one runs. And even just a visual, you can go, oh yeah, those red squares on the left-hand side are filling in a lot quicker, and we're getting some pretty decent separation between the adjacent data points as we move from left to right. So there's a virulence of 5. And let's do what every 9th grade boy in your class is going to do originally anyway, which is crank that virulence up as high as it'll go, and let's see what happens. And just watch the speed at which this one fills in. So with a virulence of 10, we reach, you can take this to the calculus level as you want. There's a limit here. If we have 2,000 or 1,600, 16,800 looks like, potential zombies, we turn them all into, or most of them into zombies in a very, very short time. Okay, now while you were doing that, on the next page, another graph was being generated. And this graph is from the actual data that we were generating on the previous page, showing you the number of humans decreasing, number of zombies increasing. And a really cool strategy that you could use here in a math or a science class, but especially in a mathematics class, is you could say, where do those two plots intersect? Now, if you do that, I mean, you could put best fit lines on here. You could put models on here that would show that intersection point, and then you could actually estimate it or find that. You'd be solving a system of equations. Now, these are logistics models probably, and if you're interested in how we can actually slap a model on there, I think nope, can't do that. So if I go here and go to analyze and go to regression, and this logistics is kind of buried way down toward the bottom. Let me just show one. There you go. Actually, it shows both of them. Check that out. Isn't that cool? Now, if we have any math people on tonight, hopefully you're kind of doing the ooh-ah thing and you're going, that is so awesome. Now, no, it didn't have the kids calculate and figure out what the logistics model was, but it certainly does put those on there, and you can say, where do those cross? Now, in this particular app, which is a data and statistics page, you can't find the intersection exactly, but you can certainly estimate. You can say, well, we're at about a little over 5 units of time, and we are at 6, 8, 10, about 7,000 zombies. So that's solving the system of equations visually. Now, I just want to go back one page. If we, and ask the group, if I go back here to, let's say, 3, and I'm going to run this thing. Whoops, did I reset it? Let me reset it first, and then I'll run it. Now, think about what the graph on the following page is going to look like now. Where will the point of intersection, where do you predict the point of intersection will be if we lower the virulence so it takes longer for the humans to become zombies? And let's see how you did. And notice another really, really awesome thing about TI-Nspire. The intersection point now is quite a bit further to the right, quite a bit more time. But notice that because we asked the device to put in those logistics models, they're still there. And they change according to the new data that we have. It's just so awesome, the dynamic of the TI-Nspire stuff. Okay, so that's I took out, by the way, I got a little spoiler alert here. This activity is way more pages than this because there are lots of embedded questions. You remember when Cassie was going through the Ghost Stories activity, there were a whole bunch of questions embedded in here. What I did is I took those out so that I didn't stumble over those. And so it kind of was more for my sake than yours, so we could actually get to the end of this thing without getting hung up on those questions. But on the real activity, which is on STEMhollywood.com, the questions are there embedded right in the activity. The kids can answer them. You can collect these using the TI Navigator software, and you can have the computer will actually grade them for you. And it's a perfect lazy man's way to do things, which I absolutely loved personally. But it's a beautiful way to not only get science and math concepts across, but also do assessment along the way. It's perfect. Okay, so let's take a look at, and I can't see the chat window, so I'm assuming that Mike or Cassie is keeping an eye on that if there are questions or comments about this. I do want to get to this one because this is one that, because it was the second, it was like the sequel to that first one. We don't typically present this as many times as the other one, but there's some amazingly cool stuff in here, and to show off the functionality not only of Nspire, but to do a process in this activity that many of you, if you're a chemistry teacher, you've done it, you do it in your classes. If you remember taking a chemistry class, this will look very familiar to you. The idea here is to try to fix this disease. Here it is, the Humans Strike Back, how understanding pH, there we go, that's a big chemistry abbreviation, could save the human race from the zombie apocalypse. So the idea here is to try to fix this disease and to bring people back from being a zombie. So we have another scenario kind of outlined for us. We have a biochemist, Stephanie, and we have the Zombie Virus Inoculation Task Force. Now, I will tell you, I don't know, I'll probably get in trouble for doing this. I wanted to not have that word, oops, excuse me, sorry, I wanted to not have that word in there. So instead of ZVIT, we take the V out of there, but that didn't go over very well with people. So I may not ever be invited back to do another webinar, but I just got my little piece in there. But the Zombie Virus Inoculation Task Force, so there's Stephanie's a big part of that. Again, like Cassie mentioned, what we're trying to also get across to kids, since these really are for students, is some of the STEM careers that are available. So here we have Stephanie's a biochemist. In the previous activity with zombies, we had the epidemiologist, okay, a disease studier. In the ghost story activity, we had a photojournalist, you know. So we're trying to bring out the opportunity for kids to think about certain careers. So we're looking at different pHs of the body here. And this is actually true. The pH, normal pH of the body is right about there. Notice it's a very, very narrow range. If you know anything about your body and biology and or physiology and pH is very strictly controlled by your body. You do everything you can to try to keep your pH stable. And anything above or below this, and by the way, 7 is neutral, so we're a little bit alkaline, a little bit basic. Anything above or below it could spell really, really bad news for a person, and in this case, a zombie. Now, in this activity, I didn't take out the questions, but changing the internal pH of a living organism, including a human, definitely could be harmful. So we bring up some big words here: acidosis, alkalosis, which have to do with the acidity or the alkalinity. Another word for an alkali is a base. The alkalinity or acidity of the patient's blood. Let's see. So we got some lab stuff done here. We bring a new word into it. Remember in the last activity we talked about zombieism being caused by a virus. It actually gets determined that this is caused by a prion. That word is, that's how I pronounce it anyway, is a prion. And I mentioned mad cow disease. That is actually caused by a prion and not a virus. A prion is just kind of a little protein that gets in and messes up cell function and stuff, and so it really causes problems, especially neurological problems. Okay, so here's our buddy again who is in stage 4, and we have him in a little holding cell or a holding tank, and we're going to try to fix him. So let's go past this. We get into a little conversation with Stephanie. Check this out. Some of you either are giddy with excitement or you're like, oh man, I remember that stuff for chemistry. I never got that. This HCl, if it's aqueous, which means it's in a liquid, that's hydrochloric acid. This is sodium hydroxide. This is an acid. This is a base. When we put those together, we get sodium chloride, which is salt, a common table salt, and HOH, which could also be written as H2O, which is water. So that's a neutralization reaction between an acid and a base. Let's see, we're going to go by that because I want to make sure you guys have a chance to see this amazing simulation. So what we're going to do is a titration here. We're going to have Stephanie, we're going to help Stephanie do a titration. And again, in the interest of time, what I'm going to do is I'm going to start this. Check this out. There's our play button. And let's get our bearings straight. Here's a beaker with ions in it that in real life, you couldn't see them, but in order to visualize this for the student, we get this thing. They're big enough for people to see. We have a graph that's going to be displayed. And then we have a setup here, which again may look familiar to you. This is a stir plate. So these are fancy things that many chemistry teachers have that have a little magnet thing in them that stir the liquid. This is called a burette that's got liquid in it, and this is a little ring stand thing. So let's go ahead and start that, and you can see that the pH in this beaker is 1, which is really acidic. So what I'm going to do is I'm going to start dribbling in liquid from the burette. Now watch the you can watch a couple of different things. There's all kinds of stuff going on here. This is a very busy page. I've dripped in 3 milliliters from the burette. pH has not changed much. And again, in the interest of time, what I'm going to do is I'm going to dribble it in pretty fast. And notice that the pH is changing, but not too much. But don't blink too many times because here pretty quick that pH is going to take off. There we go. And notice also the color in the beaker change because there's a indicator called phenolphthalein that turns pink when it becomes in contact with a base solution. So notice how this took off and the pH went way up. That's called the equivalence point or something like that, I believe. Chemistry people, hopefully they're not grinding your teeth because I used the wrong word there. But the pH really does take off once we reach that particular equivalence point. So what this one was a model of what's called a titration. A titration is most commonly where an acid and a base are introduced into one another slowly, and the resulting change in pH is then observed. And while, again, this is you saw this in the previous activity, this is also being graphed on a different it's called an app. This is called the Data and Statistics app while we were actually doing the titration. So let me go ahead here to, well, I did get that right, equivalence point. That's nice. So I'm going to go ahead here to the actual fixing of the zombie. There's quite a bit to this activity, quite a bit of text. and a lot of questions. So chemistry teachers, we've had feedback that absolutely love this stuff because there's all kinds of questions about acids, bases, and so on. So here we go. We have something that's going to look very similar to what we had before with one more window added. Rather than having the beaker over here with the ions, what we have is an electron micrograph. And before we can actually start this thing, what we need to do is zoom in on this prion so that we can see it. And by the way, this is a beaker of zombie blood now, not just some beaker of chemical in a chemistry lab. So I'm clicking on the up arrow, we're zooming in. Look at the bottom here, the magnification. We're at 100,000 times. We're zooming in, zooming in, zooming in until we can actually see the prion. Very, very cool. This is another awesome feature of TI-Nspire. We're going to go until that thing fills up the screen. There we go. And now that's what this prion is, just a whole bunch of little proteins, a whole bunch of polypeptides all strung together. Excuse me. So we're going to go ahead and start this thing. And I'm going to start dribbling in. Remember, our pH here is sort of basic. And so we're going to dribble in this liquid and see what happens to our pH. We're going up a little bit. Now, again, a lot going on. Look at that. Check that out. We've denatured the prion. Here's the prion. It just got whacked, which means it can't cause any problems anymore. So what we did is we took the blood, which was at a pH that allowed the prion to survive, and we changed the pH to a little higher pH, a little more alkaline, and it destroyed the prion in the hopes then of curing the person of zombieism. It's always a really cool thing to talk about, this next piece, which is, yeah, but we changed the pH. Isn't that dangerous for a person? Yes, it is, but also being a zombie is pretty dangerous to that person too. So we kind of run that risk. It's very not similar. I don't want to make a leap of comparison here, but when somebody has cancer and they go in for treatment of cancer and they have chemotherapy, chemotherapy is designed to kill things. And not only does chemotherapy kill the cancer cells, we hope, it also does an awful lot of other damage to other things, but you try to weigh it out, like, is this worth the risk? And most people who have chemo are saying definitely it is worth the risk. Same thing, same type of principle here with the zombie, curing the zombie. So again, another graph, same data, just graphed in a little bit different way. So based on our data, we actually managed, look at that, doesn't he cute now? We managed to cure him, symptoms have disappeared, and so on. So is this an activity about zombies or is it about chemistry? I would say more about chemistry, but with a zombie theme to get people to, get your kids anyway, to see that there might be actually a reason for and a practical reason for doing a titration. Okay. So this is very similar to the last one that we actually did. We just produced a model, back here, same kind of thing with the dosage this time instead of virulence. So we look at the zombies in human with dosage of the serum, if you will, rather than the virulence thing. And I know we are getting really tight on time, so I think we got through most of that, though, so that's good. I'm going to go ahead and stop sharing here, and I'm going to pass over to Mr. Houston so he can wrap this up for us.
Thanks so much, Jeff and Cassie. As we begin wrapping up tonight, if you do have any last-minute questions for Cassie or Jeff, please try to get those asked. I know they'll do their best to try and get those questions answered. When you leave the webinar tonight, a brief survey will automatically appear in your browser. Your feedback guides us as we plan future online events, so please feel free to share your thoughts in the post-webinar survey. As Jeff mentioned, we're really excited that the T-Cubed International Conference this year is coming to Chicago. And I'm betting that there's a really good chance that you will see me along with probably Cassie and Jeff at this year's international conference, and an even better chance that some of us are going to be presenting some really great sessions, some which may be STEM related or math related or science related or TI-Nspire related or TI-84 related. any TI technology is going to be represented really well at the conference. Pedagogy is going to be represented. Content is going to be represented. So we're really excited to share that the international conference is going to be, again, in Chicago this year. We hope to see everyone there, including tonight's lucky winner for the conference registration giveaway, which is Michaela Holes-Hunter. So Michaela, congratulations. We'll be in touch over email in the next couple of days to give you more information. But again, we hope to see you, along with everyone else, at the T-Cubed International Conference. A lot of you tonight were really excited about some things that you saw, so please feel free to keep that conversation going on any of the major social media outlets. To receive a certificate of attendance, go ahead and click the link in the chat window. Also listed is a link for the documents that were used tonight. If you happen to miss the link or it happens to not work for you tonight for any reason, please don't be alarmed. You'll automatically get a follow-up email within a couple days, and that follow-up email will contain a link to the recording, a link to the documents, as well as a link to the certificate. If you're watching this on demand, please go ahead and copy that link into your favorite browser to retrieve your certificate. If you're in need of some post-webinar follow-up, maybe you go to sleep tonight and in your dreams you think of a great question that you can't ask because we won't be live anymore. Please feel free to reach out to us. Give us a call at 1-800-TI-CARES or send us an email at ti-cares@ti.com. We'd love to hear from you. Thanks so much, Cassie and Jeff, for everything you did tonight. It was really exciting to see the new activity as well as talk about zombies, especially around Halloween.
You're welcome. It's good to be here with you guys tonight. It was really fun.
Thanks again, everyone, for being here. We hope to see everyone back online. This Thursday, again, we are running a special calculus series, webinar series, on some Thursday nights, not every Thursday, but some Thursdays. And this coming Thursday, we do have a webinar that's going to be dealing with derivatives and using TI technology. So both TID4 Plus technology as well as TI-Nspire technology are going to be represented this Thursday. So if you want to learn more, please feel free to visit our website to register for that free webinar. Thanks so much, everyone, for joining us. And again, we hope to see you back online really soon. Have a great night.